Alright, how's everybody doing out there in Math Magic Land today? This is Mr. Muscarella coming at you here with my buddy Eric, and we're going to teach you how to solve quadratics by taking square roots, the second type, where you have irrational answers. And an irrational answer, what we're going to do is we're going to look for something that's just going to have a square root with it, like square root of 2, or maybe square root of 6, or maybe 3 square roots of 6, something like that, because these types of numbers cannot be written as a fraction in any way, shape, or form. We can't simplify them. So, on with our show. Now, the very first thing that I want you to do, and you're probably going to hit pause to do this, is I want you to write these two columns of numbers. These are the first 15 integers and their perfect squares. So if I make this integer n, that column n, and this one n squared, those are going to be my two columns. So go ahead and hit pause and write down those two columns of numbers, because we're going to need that to help us when solving by taking square roots. Alright, welcome back. Now we're going to start with a couple of very simple examples here, but before we even do that, you've got to be able to look at a number like, say, 16 and recognize that if you square root 16, you're just going to get 4. But at the same time, you have to also recognize 4 squared gives you 16. Alright, so these are two concepts, squaring a number and square rooting a number, that you're going to have to be able to go back and forth between. If you had, say, the number 121 and you were square rooting 121, you have to recognize that the square root of 121 is 11. Alright, so these are just a couple of ideas that we're going to need as we go through this piece. So let's go ahead and get this out of here. But actually, we're going to take it a step further. Say we have a number like the square root of 8. When you have the square root of 8, we're going to have to simplify that. So what I want to do is look over here in my n squared column, and I want to go to the number that is closest to 8 without going over. So if I were to go to 9 in my n squared column, that's over. So now I want to go to 4. And what I ask myself is, hey, does 4 go into 8? Why, yes it does. So 4 goes into 8 twice. So the square root of 8 breaks down to the square root of 4 times the square root of 2. Now the square root of 4 is 2, so that's just going to give me 2 times square roots of 2. So that's one idea that we're going to work with here. Now, let me go ahead and give you one other example here. Say you had the square root of, say, 48. All right. Now the square root of 48, so let me erase this. Now the biggest number, the closest number to 48, I have 49 right here, so I'm going to go one backwards, and I want to try 36. Now does 36 go into 48? No. Does 25 go into 48? No. Does 16 go into 48? Yes. All right, 16 goes into 48. So 16 goes into 48. Let's see. 6 goes into something that ends in an 8 3 times, because I know 3 times 6 is 18. So let's see if that works. 3 times 6 is 18. Carry the 1. 3 times 1 is 3 plus 1 is 4. Yeah. So 3 goes into 48 16 times. So that means the square root of 48 is going to break down to the square root of 16. And I want you to write the perfect square number first, and then the square root of 3, because those two multiplied together give you square root of 48. So 16, when you square root that, that is going to be 4. So this answer would just be 4 square roots of 3. So this is a skill that we're going to have to utilize when we solve equations by taking square roots. All right, so now let's go ahead and go through and we'll do a couple of examples of these guys. So here's our first example. We're going to keep this first one simple. We're going to do, so I'm going to make this example number 1, and it's going to just be n squared equals, say, 19. Now, when you're working with square rooting, you have to remember, and this is a key mistake here, what you're going to do is square root both sides, but on the side that has a number, you're going to have to put this plus or minus with it, and then the square root of 19. So on the left side, we don't need that plus or minus, and we don't need to show the square root, but on the right side, we've got to make sure that we write the plus or minus and square root of 19. Now I look over to the number that's closest to 19 without going over, and that's going to be 16. So does 16 go into 19? No. Does 9 go into 19? No. Does 4 go into 19? No. And of course 1 does, because every number is divisible by 1. So square root of 19 cannot be simplified anymore, so that's your final answer. N is going to be plus or minus the square root of 19. That's it. Now say, for example, you get something a little bit different. Now we're going to have maybe one extra step with this. So this will be example 2, and we're going to have, say, n squared equals, say, 56. So again, same idea. We're going to have n equals, and then plus or minus the square root of 56. Now I go over to my chart here, which after a while you're going to pretty much get these memorized, and you're just going to be able to do some of these very quickly. So first, the number that's closest to 56 in my n squared column without going over is 49. So I'm going to start here at 49. 49 doesn't go into 56. 36 doesn't go into 56. Neither does 25. Neither does 16. 9 doesn't go into 56, but 4 does. So, okay, how many times does 4 go into 56? Well, one of the things I like to think about with 4 is the number 60. So if I were to think about a clock, and I divide a clock up into 4 equal segments, they're each 15 times. You know, each segment's 15 minutes. So 4 goes into 60 15 times, and this is 56 is 4 less than 60, so that means 4 is going to go into 56 14 times. So I'm going to write n equals, and I still have to keep my plus or minus, so square root of 56 is going to break apart into the square root of 4. So my perfect square goes first, and then 4 goes into 56 14 times. So the square root of 4, though, I have to simplify that to its square root. So the square root of 4, of course, is 2. So my final answer is plus or minus 2 square roots of 14. So n would have a value of plus or minus 2 square roots of 14. Now, what you have to also recognize with these, that plus or minus means that there's 2 answers. So like in the first one answer is the positive square root of 19, and the other answer is the negative square root of 19. And of course, you could write that in either order. It doesn't really matter. All right, so when you are taking square roots, just don't forget that plus or minus, and you have to recognize that plus or minus means you're going to have 2 answers. All right, so let's go ahead and take a look at another couple of examples. Now we're just going to add one other step of arithmetic in it. So let's go ahead and get rid of this, and we're going to go ahead and just do a couple other examples here. So say we're going to have n squared minus 8. So this will be example number 3. So we're going to write n squared minus 8 equals, say, 2. Now, to begin this problem, we're going to add 8 to both sides, and we would get n squared equals 10. So when you have n squared equals 10, so now we've isolated the quadratic term, the squared term, by itself. So with this, again, we're just going to square root both sides, but don't forget that plus or minus. So when we have plus or minus the square root of 10, and then I look over in my chart, the closest perfect square number without going over is 9. 9 doesn't go into 10, 4 doesn't go into 10, and 1 doesn't go into 10, so that's it. We're done. N equals plus or minus the square root of 10. Now, I think you might have this, so what I want you to do is go ahead and I want you to try example 4 here on your own. You're going to have negative 2x squared equals negative 120. So if you think you understand it, go ahead and hit pause, try this one on your own, then come back and see if you got it right. If you need to go through it together, well, here we go. So when you analyze this one, you have to notice that the x squared term is not by itself. So when you have something in front of it, of course, you're going to have to divide both sides by whatever value, whatever constant is in front of the x squared. So in that case, that's negative 2. So when you divide both sides by negative 2, right, you don't have to show this, but some people I know feel comfortable doing that. You're going to get x squared equals, now negative 120 divided by negative 2, so a negative divided by negative is a positive, you'll be left with positive 60. Now next, we're going to have x equals plus or minus the square root of 60. We kind of talked about this one a little bit before, actually. Square root of 60. So if I go over here, the biggest perfect square number without going over 60 is 49. All right, so 49, I'm going to start there. 49 doesn't go into 60. 36 doesn't go into 60. 25 doesn't, because 16 doesn't. 9 doesn't. And 4 does go into 60. So 4 goes into 60 15 times. Let me run out of a little bit of room here. So I'm going to have x equals square root of 4 times the square root of 15, because 4 times 15 gives me 60. Now again, don't forget that plus or minus. All right, now the square root of 4, of course, is 2, so my final answer is going to be plus or minus the square, or plus or minus 2 square roots of 15. All right, so to solve this one, you get a value of x equals plus or minus 2 square roots of 15. Now we're going to do 2 other examples, and that's going to be it. The first example is going to be, so this is going to be example number 5. That one is going to be 9x squared minus 10 equals 854. And then the last example is going to be 10r squared minus 4 equals, actually we're going to make it plus 4, equals 264. Now I think some of you might know how to do these on your own, so if you do, go ahead and hit pause, work them out, and then come back and see if you got them correct. So on number 5, I'm going to go ahead and start by adding 10. So if I add 10 to both sides, I'm going to get 9x squared equals 854 plus 10 is going to give me 864. Now when I divide both sides by 9, so okay, 864 divided by 9, so 9 goes into 86 9 times, because 9 times 9 gives me 81, and then I'm left with 5, so 54, so 9 goes into 54 6 times, okay, so that's going to give me x squared equals 96. Alright, and again, when we solve this, don't forget the plus or minus, so x is going to be plus or minus square root of 96. Now 96, so here, 100's a little bit over 96, so I'm going to start with 81. Now 81 doesn't go into 96, neither does 64, or 49, or 36, or 25, but 16 does go into 96. So 16 goes into 96 6 times. So I'm going to have plus or minus the square root of 16 and the square root of 6. And if you don't know that right off the bat, that 16 times 6 gives you 96, you might just have to play with it to get the number that does go into 96. And you'll come up with 16. Alright, so square root of 16, of course, is 4. So when we're all done with this one, our final answer is going to be plus or minus 4 square roots of 6. Alright, so that's it for the first example. And then the second example, when you subtract 4, you're going to get 10r squared equals 260. When you divide both sides by 10, you're going to get r squared equals 26, and then r is going to be plus or minus the square root of 26. Now if I look over here, so 25 is the closest one without going over. 25 doesn't go into 26, neither does 16, 9, 4. So I can't simplify that one any further. So we are done with that one, yo. R is going to have a value of plus or minus 26. So at this point, you should be able to solve problems by taking square roots of both sides, not forgetting that plus or minus, and even how to simplify square roots. Alright, so thank you guys for watching. Have a great day, and I'll catch you later. Peace out.